Okay, complex zeros. It's not complicated. Me, real. My girlfriend, imaginary. It's complex. All right. Anyway, so just as polynomial function can have real zeros, rational or irrational, they can also have complex zeros. Okay. So here's our real numbers. And rational is like in all of, so whole numbers, integers, and then rational numbers. And irrational numbers, these are all real numbers, okay? We can also have complex zeros. So complex means like 3 plus 2i, or so the real numbers plus an imaginary number, that's a complex number. And really, like the number 2 is a complex number. It would just be like plus 0i. Okay, any number is really a complex number. So here, we want to find all zeros of the following polynomial function, simplify all irrational and complex solutions. So x to the fourth minus 4x squared minus 12. And we're using the same stuff we did last time, the rational zeros theorem. But this one we can factor. Remember, like if it was x squared minus 4x minus 12, we could factor that easy. It'd be x minus 6, x plus 2. So we can do the same thing here, and it'll be x squared minus 6 and x squared plus 2. Then we can set those both equal to 0. So I get x squared equals 6, so x equals plus or minus the square root of 6. Here I can subtract that and then square root it. So I get x equals plus or minus the square root of negative 2, which square root of a negative is an I. So plus or minus I square roots of 2. So our zeros are square root of 6, negative square root of 6, I squared to 2, and negative I squared to 2. If we wanted you to write the function out, this would now be f of x equals x minus the square root of 6, x plus the square root of 6, x minus I square root of 2, and x plus I square roots of 2. Cool? Okay, let's do another one. So negative 2x cubed minus 16. Well, we can factor out a negative 2 here, and I get x cubed plus 8, which this is the sum of cubes. So we're going to use this SOAP thing. So that's going to be x plus 2 and x squared minus 2x plus 4, which that x squared minus 2x plus 4 does not factor further, so we have to use the quadratic formula. That first one is easy. We get x equals negative 2. This one we have to use quadratic formula. So then this is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So that's going to be negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4 all over 2 times 1. So that's going to be 2 plus or minus the square root of negative 12 over 2, which is 2 plus or minus 2i square root of 3 over 2. Which that 2 divides into both of those, so that's the same as 1 plus or minus I square roots of 3. So our zeros are x equals negative 2, 1 minus I square roots of 3, and 1 minus I square roots of 3 and 1 plus I square roots of 3. If we wanted to write the polynomial function here, this is going to be f of x equals x plus 2, because I just added the 2 over. This one would be x minus 1 minus I square roots of 3, because I just subtracted both of those. This is going to be x minus 1 plus I square roots of 3. Okay. All right, list all possible zeros, then find the zeros. So again, we can try to just factor this, which this one doesn't factor. So then we're going to use the P over Q. So we have 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48 for the factors of 48, and then 1 for the factor of Q. So there's all our possible zeros, and then we're just going to start plugging them in, see which one gives us 0. So f of 1 equals 63. Does not work. F of negative 1 equals 29. Does not work. F of 2 equals 80. Doesn't work. F of negative 2 equals 0. Perfect. That works. So then we're going to use synthetic division with that negative 2, and you end up getting x squared minus 4x plus 24 when you go through that synthetic division. Okay, so that means that before we get into the quadratic formula, this is going to be f of x equals x plus 2 and x squared minus 4x plus 24. Okay, so we found one of the zeros. One of our zeros is x equals negative 2. Now we have to factor this, which it doesn't factor, so we have to use quadratic formula. So if we use quadratic formula here, that's going to be negative 4, negative 4, plus or minus negative 4 squared minus 4 times 1 times 24 over 2 times 1, which is 4 plus or minus the square root of negative 80 over 2, which the square root of negative 80 is the same as 4i square roots of 5, which 2 goes into both of those, so we get 2 plus 2i square roots of 5. So our zeros here are x equals negative 2, 2 plus 2i square roots of 5, and 2 minus 2i square roots of 5. So we could write this, if it asked for the function, this would be x plus 2, x minus 2i square roots of 5, and x minus 2 plus 2i square roots of 5. Okay. Okay, complex zeros and the fundamental theorem of algebra. So a polynomial function of degree n, where n is greater than or equal to 1, has at least one zero in the complex number system. Okay, remember any number is really complex. So that's just saying that you're going to have at least one complex number, given that all real numbers are also complex numbers. Okay, and then linear factorization, that's what we've been doing. This means that all polynomial functions can be factored completely, okay? So let's give this one. So we want to find the zeros. And this is really everything we've been doing. It's just like reiterating it, putting it in some words. Find the zeros and then find the complete factorization. So if we find the zeros of this, we want to see what multiplies to be negative 36, adds to be 35, which is 36 and negative 1. So that's going to be 9x to the 4th plus 36x squared minus 1x squared minus 4. We can group those. So I can pull out a 9x squared from the first ones. I can pull out a negative 1. So I get 9x squared, and then x squared plus 4, negative 1, x squared plus 4. So I get x squared plus 4 and 9x squared minus 1. Now we can set these both equal to 0 and just square root them. Or if you remember difference of squares, this one is the difference of squares. This one is the sum of squares, which is what this little I is looking at right here. Okay. Remember, sum of squares can factor over the complex numbers. You just put the i's in there. So that means that this x squared plus 4 factors to x plus 2i and x minus 2i. And then 9x squared minus 1 factors to 3x minus 1 and 3x plus 1. And you can get that also by setting it equal to 0 and then just solving it with the square root method, which means that our x's, so that's our complete factorization, and our zeros are negative 2i, 2i, 1/3, and negative 1/3. Okay, let's do another one. So x cubed plus 6x squared minus 14x plus 16. So this one can't be factored, so we have to use the rational zeros theorem. So we have 1, 2, 4, 8, and 16 for the factors of 16, and then just 1. So that's 1, 2, 4, 8, and 16 are the possible zeros. So I'm going to plug in 1 and I get 9. Does not work. Plug in negative 1, I get 35. Does not work. Plug in 2, I get 20. Does not work. Plug in negative 2, I get 60. Does not work. Plug in 4, I get 120. Doesn't work. Plug in negative 4, I get 104. Doesn't work. 8, I get 800. Nope. Negative 8, I finally get 0. Okay. So then I can do synthetic division with that negative 8. And I end up getting x squared minus 2x plus 2. Now this cannot be factored, which means I have to use the quadratic formula again. Okay, so this is going to be x equals negative 2 plus or minus negative 2 squared minus 4 times 1 times 2 all over 2 times 1, which is going to be 2 plus or minus the square root of negative 4 over 2, which the square root of negative 4 is 2i. And then 2 divides into both of that, leaving us 1 plus or minus I. Okay, so that means that our zeros are x equals negative 8, 1 plus I, and 1 minus I. So to find the complete factorization, we can just set those all equal, and then we're moving them over. So that's going to be x plus 8. That's x minus 1 minus I. And this is x minus 1 plus I. So the complete factorization is x plus 8, x minus 1 minus I, and x minus 1 plus I. Okay? This one. So x cubed minus 11x plus 20. So again, cannot be factored. So we have to list out our zeros. Our possible zeros are 1, 2, 4, 5, 10, and 20. So negative 4 equals 0. And I just cheated there, but it's okay. So then if we plug in, or we do synthetic division with negative 4, I end up getting x squared minus 4x plus 5, which we have to use quadratic formula again. So that's going to be negative 4 plus or minus negative 4 squared minus 4 times 1 times 5 over 2 times 1, which is 4 plus or minus negative 4 square root of negative 4 over 2, which is 4 plus or minus 2i over 2, which 2 goes into both of those, so you get 2 plus or minus I. So our zeros here are x equals 4 from plugging it in, and then 2 plus I and 2 minus I. So to find the factors, or the linear factors of this, that's going to be x plus 4, x minus 2 minus I, and x minus 2 plus I. Okay. Well, I think we are done here then. Okay, that's all. Miss you guys. Bye.